to the theory group that this is that the bits of the final co-argument you're hitting are in the range of this upcast.
Yeah.
So I think it's the same problem we just discussed.
Yeah, I think we should move on and perhaps return to this topic later on.
Can I add something? Well, let's take it first.
Yeah, well. Yeah, sure. I mean, I'm actually getting to, well, if you, yeah. Great. Do you want to come up front as well? Just, so Ron and I are going to try to moderate this discussion somewhat, and I'm very curious what they will write down, but just as an introduction, let me say again that this arose from, or the idea for this theme of just discussing challenges and open problems arose from my personal experience that I was a researcher in generic programming for many years, and I've been developing all sorts of generic programming libraries and tools, and I've written example programs in generic programming, and then I switched to industry about 2 years ago. And actually I have to admit that I have been able to apply generic programming successfully almost never.
Is that because of the bottom one?
Well, that's one of the things. There are actually a couple of things. This made me wonder, like, why is this actually? And yeah, so just to not go into the details right yet, but I think the main reason is that as an academic I had the chance, as an academic I succeeded, as an academic I had the chance to choose my own problems. And I could choose problems that are suitable for generic programming, whereas in practice problems seem to be almost suitable for generic programming, but if I actually try to do things, then things tend to break down here and there. So I started wondering, have I actually been solving the wrong problems all the years or something like that? But instead of actually going on and just talking about my problems, I would just like to use this as an incentive to give all the crowd here the chance to say what problems we should actually work on during the upcoming years. What are the most important problems we should focus on? Where is the most need? And where do we think that there is a potential for perhaps real breakthroughs? And ideally, we can set ourselves some challenges and even work on perhaps making the challenges more concrete and have some problems that we as a community can refer to again in the future and say, oh no, we actually managed to solve something and do something good. Okay, so if I look at the list, I have written down something cryptic here, which is static, but which is actually very much related to efficiency. Tool support is another point. I have been talking to lots of different people about things that have to do with types. Well, not really surprising. But yeah, there is some issue there as well. And Jeremy has a very philosophical. I'm not sure. So I think there is types in the widest sense, there is efficiency in the widest sense, there is tool support in the widest sense, and perhaps there is focus or direction. So those are four different topics.
And there is expressivity, I guess. What can you express using a program?
I guess that goes into that. I think that goes into that direction. And
so what I'm struck about here is as has always been the case, as we designed this workshop series to be, a meeting point between people doing different kinds of generic programming, different interpretations of the term. And so what I meant by that part was a hint as to generic programming in the sense of generic ASCII see more about the connection between them, rather than us, each of us contributing something at one end of this continuum to try and find more ways of connecting them.
Well, maybe we should have something specifically for this purpose. Like what, maybe 2-3 years ago, I wrote a piece of program that simulates your stuff in C++, and I never had funding to use that.
Well, that's difficult to arrange. It's certainly not something we can achieve here. But,
Yeah, well, just in general.
I guess what we can achieve here is to like make the problem sound so concrete that it may become more realistic to get funding for it. But
well, I see it becoming a more realistic prospect with I mean this has been channeling Randy Bullock from 12 years ago again. Dependent types is what you want. I mean, you parameterize your programs with some structure, and whether that structure is the centering for which you do shorter class algorithms, or whether it's the universe that you use for encoding your family of data numeric functions. It's just a parameter, and they're independent type program. It's the same kind of parameter as well.
yeah, so this gets me to one of the points that I'm struggling with. So that's at least if I go to the level of dependent types, I get to a point where I can express most of the relations between things in my program. Like if there is any kind of abstraction to be found, I can usually program it in some way. But it is still an encoding. And so if I have a relation between two different data types and they're connected in some way, and I can actually write a universe and somehow beautifully generate both data types out of it, that doesn't mean that the resulting thing is anywhere near nice to program with or practical to program with. In fact, it's usually quite horrible to program with. And so it's one thing to understand how the things are all beautifully and mathematically connected. And I think we're actually relatively good in that. There's a lot of work that has been done over the years in the category theoretical direction. There's a lot of work that has been done over the years in a type theoretical direction. But there is not so much, I think, that is like targeted towards the user interface of it all. And there is the other side of the medal, certainly, that there's also not enough work in order to reason about the efficiency of it all. I mean, even if it's all nice to write down, it's not necessarily at all anywhere near efficient. And so for me, I often get into the problem of I want to write something down, and I have a choice between making it incredibly ugly but precise, or making it reasonably easy to work with but imprecise. And that was, I think, the theme of the first talk today a little bit. And I very often opt for the imprecise way, just because that's what I can more easily sell also to other people who look at it, which otherwise would ask me, why are you doing this or something? And the other thing is efficiency, where I would even say it's not so much the actual efficiency, but it's the reasoning about efficiency. I very often get the impression that the generic programming is sort of, oh, sometimes it's optimized well and sometimes it's not optimized well. But I never have any idea when is when. And so a more formal approach also to efficiency. No, I've been talking.
Regarding efficiency, so there is this library in C++ called the Proto library, which is sort of cheating the compiler by using expression templates, and as a result you get things that for an ordinary expression, you make the compiler, instead of giving you the result, it gives you an ASE which represents that result. And then people have been developing in this area, whose this guy who the name is posted a number of things, and he had very nice measures about the efficiency actually being better than hand coding. So yeah, yeah. I mean, it's because you are moving things to compile time. The compiler can do more. So that's one thing. You wanted numbers like I think I can provide it.
So I mean, I think C++ has the great advantage there. There is a clear distinction between what happens at compile time and what happens at runtime. You know,
Right, yeah.
I mean, they look totally different. They behave totally different. Whereas if you do, I was mainly concerned with sort of Haskell libraries, where you don't really know what's going to happen. The compiler might do something clever, or it might not.
Right.
So I want, as you said, I want more control to know for sure that something's going to happen at compile time,
Yes.
like I can in C++.
That's exactly why I wrote static over. I mean, so I would like to have some easier way over there. Yeah.
So it's actually a little worse even though, because even in C++ you can use expression templates to do some tricks, but ultimately you're relying on knowledge of the few compilers that are out there to get many of them to work. There are some cases where these techniques are specifically dependent on how good the compiler is. I mean, it used to be the case that the Cook and Associates compiler was what everyone was dependent upon, and to some extent it set the bar as far as how good your expression template code would ultimately compile down to. Or you depended on particular individuals who are very good at making things work with many compilers. So the reasoning about efficiency, as Andrew is talking about, is still a problem even in that community.
But also, correct me if I'm wrong, my understanding is that C++ templates suffer from a similar problem that template Haskell, for instance, also suffers from, is namely that it's essentially relatively type unsafe. And often we have approaches that you're given again a choice between like relatively sophisticated type level approaches that blur the whole distinction between what happens statically and what happens dynamically, or relatively straightforward meta-programming mechanisms that make that very clear, but essentially force you into a comparatively low-level programming paradigm and leave you with a lot of unsafety. And there are certainly like programming languages specifically designed for stage programming, but I'm not sure how far they are coming towards the practically usable side of things. So is it perhaps the time to like look at dependent types and meta programming and disciplined approaches to templating and staging and try it all again? Or is that not the right way to go? Or are there other options out there? Or
so if you have an indexed template Haskell, so to say, or a type template Haskell, that your reflection also keeps track of the types of expressions, then you can have type-safe template into programming.
yes.
I mean, Tim Shear has been doing this kind of stuff for so then you know you are generating code, so you know how it's going to look like, and hopefully you know it's going to be fast enough. And you have the type safety that you are asking for.
But this hypothetical beast, we don't know how pleasant it would be to use, actually.
Yeah, so I'm already afraid that I will not use it.
And it would change every 7.6, 7.8, and the names would change.
Yeah.
Well, okay, that's yet another problem. But so this, like, is this something that is going to be in GHC, or is this something that's going to be developed separately as an experimental language?
There's a proposal for a type template Haskell. And the proposal is quite developed. I don't know if there's anyone actually working on it or if they take any significant cost.
Who proposed?
I don't know. I know there's a wiki page for it. I think it's Simon. Yeah.
He wrote that proposal, of course.
Okay. I know he's at least keen on the idea. So the other direction, so if you just have these high-level libraries and you don't know how they're going to be optimized, so I have done work in showing that you can, the compiler can by itself eliminate all the representations and optimize them at least as good as to type-specific code. But to actually get a proof that this will always work, you need a formalization of the inline.
It's actually very easy to prove that it will not always. I mean, that in practice it will not always work, right? I mean, at the moment it's very easy to write down a program that will not optimize.
It never works in practice.
No, I mean, I don't really demand the proof that it will always work. If I get the feeling that it always works, it's perfectly fine with me.
I would be happy with some kind of pragma I can put on something, saying that I expect. I'm not quite sure what the pragma would look like, but something that says that I expect all of this to happen at compile time.
Right, but
so if you have a pragma that said, I don't want these guys to ever be there in my final code,
something like that.
and then you take the representation type and you say, you should never be
And
there.
if the compiler could, I mean, as a first approximation, I'm happy to, well, if it just says, sorry, I couldn't do it.
Use the code.
Yeah.
yes, okay, but you would still want to know about it before you run it.
Yeah,
I mean, you want the
and
compiler to
then I
tell
can
you.
tweak it until the compiler says,
Because-
yes, I did it.
I mean, at the moment, well, you have all these sorts of inline and inlineable and whatever programs, but you never have any idea what's
Never
actually.
works for me. So
Yes. But let me ask, or
Well, actually, in the deprogramming language, and I'm not a deprogrammer myself, but I have watched a number of talks. So in the deprogramming language, apparently there is something called mix-ins, and they do have exactly what you said. They have these mix-ins are, as far as I can understand it, they are compile time string processing facilities, and they have a notion of purity. So if what you do is pure and you specify it as pure, then they would do it at compile time. And if they fail to do it, they will emit a compile error.
yeah.
That goes back to the usable aspect of this. That it sounds like there's aspects that, in a sense, go beyond the theory at this point about what is the end user interface.
Yes, so I would be interested in, you said you want to use it, but we're not able to, and we have similar problems in future. So I would want to, we have a big Haskell system, 26,000 lines, and we want to use generic programming techniques there, but then we certainly have data types that have non-encoded invariants. There you go, possible anymore. Then one of the programs inserts data map instead of a normal list. Well, out of the, so there are all kinds of practical things which stopped us from doing it consistently throughout the system.
Abstract data types are a problem, yeah.
Abstract data types are a problem. So using standard module functionality as a problem. It's kind of these practical things that you can't go halfway. I mean,
So I actually often have situations which, not necessarily now for a simple compiler, but I mean, I'm phrasing it that way. Assume I'm writing sort of an evaluator for some kind of programming language. I have several evaluation steps similar to what we saw in the first talk today, but then I have far more than just a subset situation. I have data types that are related to each other, and I would like to program in a practically useful way things like, well, yeah, actually these three fields appear in these two data types. They're actually the same, but this fourth field here is replaced by something in this other data type that is related to the original one according to this. And again, I'm in a situation where I know with ornaments or with universes, and I can actually program this. Yeah, sure, but it's not in a way that I would ever want to use the result at the moment. And I'm not sure how we can get there because we have this very much name-based approach in Haskell to data types. So it's very much like relying on what makes things nice in a language like Haskell is that data types are named, the constructors are named, and then I'm defining all sorts of related data types. And whatever I'm going for in a computational approach, these related data types will never be really first class. So is there any way or any idea of how to like introduce new first class things like data types, or should we just abandon them altogether?
Just abandon them altogether. There is no data type genericity while there is still data type generativity. You know, end of.
Well, how do you make it practical, right? People want names.
That's done at the elaboration layer.
You just want all that to be syntax.
Yeah, that's the syntax.
But even if you say it's just syntax, you have to sort of put your cards on the table. I mean, how?
So all the stuff about the presentation of the data goes in the code that describes the type.
Yes.
Not in the type itself, and that is enough to do a type-directed elaboration of readable stuff in terms of the lower level encoding.
But you still need some disciplined language in order to do the presentation description.
Sure.
And, so you have to, I don't know, in some way compute or form new names out of old names if you want to have it practically usable, and I have not yet seen.
But I also want it efficient.
The best way to achieve an efficient language is never to
Never to run your program.
Then all the programs you can compile run really fast.
Yeah. But I want existence as well.
I think it's also the case that the more of these abstractions you perform, the more you really need good specialization in technology.
Yeah, and you want to know, you want to be able to control it so you know that it actually happens.
Yeah, so that's so there are real expressive advantages in making the different phases look an awful lot like each other. But at that point you then need to have more explicit control over which phase things are sending to. You're sending stuff to, you can't just see what phase something belongs to by what it looks like, because all the phases look the same now. So there's certainly room to look at kind of phase annotated calculating.
But in a way, it's not special to generic programming, of course.
No.
Just any abstraction you introduce.
Absolutely.
Needs to be,
but I mean, I think you see it even more when you
it gets worse. It gets worse here.
Yeah.
Here you sort of get 100 times slower program because you're having.
I mean, I have to write my own library for generic programs.
And that solves it. And that solves it all.
So my problem, my problem.
No, but so in clean, there is the compiler guarantees that all implication, so the codes, the type representations have been compiled away.
Yeah. If your functions and their use are in the same module, because it doesn't do cross-module stuff, and it only works
if
for
you
that.
really ask Linus, then it's well, yes.
So one thing from this list, I think that we haven't talked about yet is the tool support. So perhaps you want to say what.
Yeah, well, I joined Hamburg University of Technology with the mission of making life easier for generic programmers, and I have been struggling and finding things which make this possible. At the moment, I have only so far looked at what is called the language definition of environments, and they are far from anything that gives enough understanding of the production of the language when you want to test it, for example, for generated program. So I don't claim that I've looked at everything, but anyway, long story short, I'm just saying that I don't at the moment know of any tool which can make generic programming easier. anyone does, please.
Well, one thing you can do probably is, I mean, at least I often go by example, and then try to abstract from that. You could have tool support to help me to abstract from the examples, doing some refactorings, well, not actually refactorings, but code transformations. That, like what we just saw in the last talk, right? You have this generic algorithmic descriptor like swap, and then now you want to introduce downcasts and upcasts. And now you can have a tool support for introducing these kind of things.
So that in the last talk you would have wanted to find this replacement of list by the type variable, right? That seems extremely hard to automatically.
You can't suppose that programmers would do that.
You might hope that your refactoring tool could be guided towards that.
Okay. Yeah.
Well, it's not an automatic refactoring or anything. I mean, I need to tell it what to do, but it should be easily configurable or applicable to my specific settings.
But you might take the type specific one from the POM and the polymorphic type of the thing you're wanting, and ask what do I need to delete from that to get something like this on.
Error correcting type checker.
Yeah.
I mean, that is,
Refactor.
I mean, you've got this type, you've got this program, it doesn't quite fit, so take this off and this one here. We should check with Deutsche. I mean, it's good at error correction.
So getting programs run is one thing. The other is that I want to introduce, for example, this sort of generic programming, this trick in generic programming to my language. I want to get it designed. What's the outcome of that addition to my language is another. Does anyone have anything on the second? So for example, okay. So the paper by Patrick and a number of other people within issue who I'm working for studies the commonalities between C++ concepts and typecasting in Haskell. There are other papers, I think, including you as the authors, that study generic programming as a more general thing to consider between the two, and the punchline is that they're very similar, but very similar in the sense that we know that they do have these features. What is the formalism behind this similarity is something that we haven't still studied. So does anyone know about how to formalize the commonalities between the practical generic programming across languages?
Yes, that's basically what you mentioned.
Well, so actually, Ralph Hinton and I do have the project that's playing Pedro, which is a new project on unified theories of programming. And the motivation behind that is to try and find categorical, perhaps, explanations of what it is that's in common between all these libraries. And how we get through it.
Okay.
Yeah, also, I mean, at one point, I think at an earlier conference about generic programming, there was the attempted definition that generic programming is trying to add the abstraction to a language that isn't natively supported yet. So in that sense, like generic programming originally in imperative object-oriented languages often meant just parametric polymorphism. In Haskell, it originally meant data type polymorphism. Now there is a lot of points to be made that there is an even wider categorical sense. But what's the, like, in the language development, perhaps where are we going to? I mean, we have been like stuck with abstracting over, say, categories or data types, or in some way, or structure of data types or patterns like this for quite a number of years. But is there a next thing that is coming at one point, or are there more things where we should be considering that we're always forgetting, or do we even have reached like the point where we have a complete overview of our own field?
Surely not. No, I don't expect that the work that Pedro and I and Ralph are doing will answer your questions about usability of generic programming. The compromises of precise characterizations and flexibility versus convenient interfaces.
Yeah, although I would of course hope that there is a non-ad hoc solution to this problem as well. So you can always say, oh, usability is really different from theory because it's just about usability. But in my experience, the best solutions are the clean solutions. So ideally, I would like solutions to even the usability problems that are grounded in theory. So, and of course, I mean, I hear Connor when he's saying you have to just do this and this and this.
I think I inserted the word just.
No, I deliberately did that for you. But you implied it. And
no, I was saying what you needed to do, at least.
I would still think, yeah, I would like to hear more about ideas in that direction, certainly.
I actually think that there's a tension between the usability of generic programming and type systems for generic programming. Because, I mean, if I don't have a statically typed language, and if I do just dynamic types, then generic programming is just simple, right?
Then there is no then there is no generic programming.
Well, except that it's not. I mean, data type generic programming still is an issue if, say, you're in Scheme and you're defining record types. Even if your types are entirely dynamic in terms of variables, the instant you start being able to create new types, dynamic types, you get back to the same issues.
Yeah.
And certainly in terms of the constrained parametric polymorphism, you know, type classes and such, to find out how do I do this on a particular type. You know, even if I don't know the type at compile time, that dispatch still has to be done somehow.
Of course, you're right that type systems are always in the way. In a way, generic programming is just you can see it as just a way to get rid of a certain amount of the typing discipline in a theoretically sound way again. But it's also
I disagree with that entirely. The whole point of generic programming, as I see it, is to get the benefits of a dynamically typed language and flexibility, while still having the static checks.
To me, that's exactly what I've said.
So I mean, as we identify, as I said many years ago, to some degree, dependent types is a natural setting for generic programming. But there still is the question of what is the, I mean, maybe one of the challenges is to make Agda executable. I mean, Agda is executable in the sense there is a compiler for it, but I'm not sure what quality it has and
It's
how.
not just that, though. I mean, certainly there is the problem of generating good code for Agda, but there is also still a problem of having, like, even just being able to write down these things in Agda is not necessarily meaning that they're reusable. And I don't see that yet either. And there's also the other side is also that in Haskell, with adding more and more of these type system complexities on top, it's not only that the language is getting more and more complicated all the time, it's also potentially evolving to have efficiency problems which used to be the sole domain of dependently typed languages. So if you if you start like programming lots of stuff on a type level, it's not so hard to make GHC take literally hours to compile your program. And if you start carrying around proof terms everywhere, it's not so hard to incur a lot of performance overhead in Haskell code that like you used to complain about. That is the problem of dependently typed languages. So yeah, I think like, solving efficiency is efficiency problem is certainly a major point there, but you have to make things usable at the same time. It's not.
So one thing that's used a lot, I don't know if you call it generic programming, is deriving, right? If you look at, so we analyze package, and analyze the usage of generic programming techniques, and deriving is in half the package at least.
What?
Sorry?
Deriving
sure. So that's been extremely successful, I think. And also probably because it's rather easy to use.
And it gives you what you expect.
It gives you what you expect, it's in the language.
As long as there are new variables.
Sorry?
Oh, yeah.
As long as there are new variables.
Well, another big thing about deriving, like for me, is that you know at least to a certain bare minimum that it's efficient. I'm thinking in particular of show. Where it's like you have show prec, and if you actually write your show instance, a lot of people just use show. They don't use show prec. Whereas the derived instance uses the smart way of doing it.
But it's not generic programming because each of those derivings has been manually encoded by someone else, right? So that's the.
Why doesn't generic programming offer the same kind of advantage? I mean, you would expect so, but that's the claim. If we write a generic function, we make sure that it compiles to faster code than you would write by hand.
Right, aren't there classes like various serialization and stuff that are basically written using generic programming mechanisms outside at the user level that are commonly used?
Yeah, there is this C regular or C regular.
Or there's a derived program that can provide all of these things.
But there you get no guarantees that the code generated is actually any good or any fast, right? It might involve at runtime converting to some products, doing something there, converting back.
Yeah, that's out of the question.
Whereas with the deriving stuff, you know this doesn't happen because Simon wrote the code that looks at your data type and generates. So, but that's not generic because it only works for EQ.
It's somewhat generic.
Send an email to Simon.
Oh, but that's what happens. Then you go to Simon and you say, but everyone is using font turn traversable. How do you make this derivable? And spend one day or two, and then yes, but
It's gotten slower.
We have one generic function.
yes.
Very efficient compiler.
It's just stage computing. It's the first stage can be slow, but once you get the code, it's good.
You know, works very fast.
Yes, I think Connor's approach is great. I mean, just kill the data type, and then you don't have data type generic programming problems. That's,
I also think it's definitely important that we keep exploring new languages in parallel with trying to extend existing languages. Because if you work within a particular language, you're becoming blinded to the obviousness of certain solutions. Well, every once in a while, you just have to look at the problem and think about what's the best solution for this problem. If I'm not constrained by any of these practical concerns for now, and then perhaps you come up with a good language idea, and then you can think about, oh, can I actually do this in the existing languages as well in some way? But if you don't take this intermediate step of exploring and trying new languages, I think you're removing a lot of the design.
Support for that?
sorry.
What is the tool support for that? So I want to have a language that, let's say that I want to have a language that has good support for generic programming. How fast can I get that? What tool can I use for that? Do we have any?
How fast can you program?
And now you probably have to send Leonard an email. compiler per day. And then it's a generic, no, but yeah, so this gets into the direction of, like, it would certainly be helpful to have yet better tools to explore with languages and try out new things and try out new programming languages quickly.
But it's going to take years till any new language has any level of support near what Haskell has now, and libraries and etc.
Well, that's not the main point of doing it, right? I mean, some of them may evolve over the years into languages that are actually widely used, but even if they're not, they can serve as an inspiration to, like, let the other languages evolve into directions where they wouldn't have like evolved towards without that. I think, for instance, if you take dependent types on Haskell, it's very obvious that if none of POC and ACTA and epigram and Idris and whatever would be in existence, I don't think we would be seeing all these developments that Haskell is currently taking.
Yeah.
And people would have tried very different things. I think you need to just try things in order to.
But if you really want a different paradigm, you will not be able to port it back to Haskell.
You never know. I mean, I would have said you'll never be able to merge functional programming into imperative programming. And perhaps you aren't, but still people are trying.
What do you do with programming in Haskell?
Yeah.
Everything is possible.
Okay.